Hey everybody, and welcome to another Android tutorial in our series from the electronicarmory.com. I'm your electronic armorer for Android, and for this tutorial we'll be discussing databases and how to save data between application launches, or in other words, persist that data. We'll also show you how to retrieve, update, and delete that data. We'll also show you how to link to other objects that are also stored in a different database table. Now you could do this manually using Android's SQLite Open Helper class, or you can abstract that functionality and use what's called an ORM, or Object Relational Mapping, which is a design pattern for accessing a relational database from our Android code as plain old Java objects. The ORM we'll be using in this tutorial is called Active Android. To see a list of other ORMs you can use, make sure to visit our website to see a list of popular ORMs you can use for your Android app. Each one is different, so you should choose the best one suited for your particular application and tastes. Even though we'll be showing you Active Android, many of these concepts apply to other ORMs. Each have their advantages and disadvantages, so make sure to head over to our website, links in the video description below, and check some of them out yourself. Active Android is a very powerful tool as you don't have to write a single line of SQL code, which is error-prone due to the fact that you have to write and construct long SQL commands as strings where errors can't be detected by the compiler. Instead, in Active Android, you simply mark up your Java object model using Java annotations, extend that Java class with the model class, and you simply save that model's data to the database by calling the save method on that object. To update the data, just update that same object and call save on it again. Active Android will determine if the record is already in the database. If so, it'll perform an update. If not, it'll perform an insert operation. To learn more about databases, I have a previous video on databases that you should watch. Sample code for this project will be provided via a link in this video's description below, or visit our website electronicarmory.com. So if you're ready to save and retrieve some data from a database within your Android application, let's get started. The first thing that we're going to do is open the Active Android website on GitHub. They have a nice tutorial on how to get started. Let's follow this tutorial so that I can show you how to install Active Android as per the documentation. Now you can install Active Android from a jar file if you want to compile the application yourself. You can install it from Maven, maybe perhaps if you're using Eclipse, which is now deprecated. But since we're using Android Studio, we want to install it via Gradle. So let's scroll down to the bottom where we see installing with Gradle. If you've ever installed a third-party library before, the compile directive will look very familiar to you. There's an additional step, however, and you have to add this Maven repository to your Gradle file. So to do that, we copy the repository's links here and put this in our build.gradle file. So we'll switch over to our application, go to our Gradle scripts, open that disclosure arrow, click on the project's build.gradle file, and you should see the repositories option. The one we're going to use is under all projects, under repositories. So paste the code in below. Now you can see that goes in the repositories option. If we switch back to the documentation, you can see we have the compile directive here. So copy that, go back to your Gradle build file, but for this one we're actually going to go to the projects build file. So click on that and find the place where you see the other compile options. So I have two at the bottom here, so I'm going to place this at the bottom, and that's all we have to do. Since now that we changed our Gradle file, we have to now sync those Gradle files to our project. We can do that one of two ways. You can see that there's an orange bar at the top that says sync now, or we can go up to this little Gradle icon which has a little down arrow. Gradle will sync that file to the project. Give it a few seconds. Okay, and what Gradle's done in the background is actually download the files that we need for Active Android. So now we can just start using it in our application. Let's switch over to our manifest file. And now if we go back to the documentation, it's telling us that we need to add the Android name as com.activeandroid.app.application. And what you're essentially doing is subclassing your application class, which runs your Android app, and subclassing that from their app.application class. So let's go ahead and copy this string, and going back to our Android manifest file, and pasting that in as the last attribute in the application tag. Okay, and so this is allowing Active Android to embed itself within your application so that it can perform the things that need to be done. If you don't like this method, there are a couple other methods that you can use for Active Android, or you can use a different ORM that uses a different method. Now let's go back to the documentation, as there's two more items we need to add to our Android manifest file. We need the database name and the database version, so copy these two lines of code from the documentation and paste them into your Android application, into your Android manifest file, under your application tag. So inside the application tag, paste that code in and change the database name to something that's a little bit more applicable to your application. Next, we have the database version. In this example, the database version is number 5. Since this is our first version, we're going to change this to 1. Now, as your application matures and you start adding different attributes to your database, different fields, columns, you're going to have to migrate that database schema from one version to the next. And this is how it keeps track. When your application is running version 1 and it gets updated with version 2, you can track those changes and you can perform necessary database migration scripts depending upon which version you're on and which version you need to upgrade to. So we're done with the Android manifest file, so we'll switch back to the documentation and go to the next steps. Scroll down until you see the code that talks about how to set up a table and the columns. You can see from this example that they're using categories and items. Click this link here to create your database model. So this page talks about creating your database model. If you scroll down, you can see the example code. Above your Java class, it's going to extend the model class. Before that, we have a Java annotation table with a parameter name equals items. Inside of that, we have an annotation column with name equals name. And in that table, these are going to be your column names. For our example, we're going to set up an application that keeps track of GPS locations. So we're going to have 2 models. One of those models is going to be called location. Location is going to have a name of that location as well as the description of that location. It's also going to have another object inside of it called coordinates. And these are going to be 2 doubles that we're going to call latitude and longitude. However, this object is going to be a separate Java class, and we're going to link these 2 classes together. You can see from the UML diagram how these relate. So let's go ahead and create those models in Android Studio. In our package, you can click on your package name, hit Command-N or right-click, create a new Java class, and I'm going to call the first one Location Model. Okay, so we have our location model here. And referring back to our UML document, we have 3 attributes. One is a string called location name, location description, and the third item we have is a coordinate, and we're going to call that location coordinate. Okay, so the class is red because we haven't defined that, so let's do that now. Right-click your package, go to New, Java class, call this coordinate. Okay, so here's our coordinate class, and inside of our coordinate we have 2 doubles, latitude and longitude. Alright, if you have a previous application that you're working on that you want to retrofit with a database, you might have something very similar to this. In order to retrofit a database to it, it's very simple. Just add those annotations that we talked about. So let's switch over to our location model really quick. Switch over to our documentation, and you can see above our class decoration, we have @table name equals items. Let's copy and paste that in. Import the libraries by hitting Option-Enter. And changing items to locations. With database tables, you usually add an S because database tables contain multiple items, in this case location objects, so we usually add an S. Going back to the documentation, each member in our class needs to have its own attribute for column. Let's copy and paste that into our code. Import the libraries and change the column name to what you want. The column name doesn't matter too much, but it should be something that you understand and is explanatory to what it is. Next, we need to extend this class using the model, import the library. Okay, and finally for our coordinate member, we need to add one more column for that as well. Since coordinate is an entirely different object that we're also going to store in our database under a different table, we still mark it as column, and under the hood, Active Android will mark a foreign key to this record so that we can relate these 2 different objects together in our database. All right, so let's annotate our coordinate class now. So we start out the same process, and I'm going to do this really quickly. Also, Active Android expects these members to be public. Okay, going back to the documentation, we see that we initialize Active Android using this line of code and passing it the context, which is this. We call this line of code in our onCreate method in our main activity. What this will do under the hood, besides many different things, it'll create our database file if it doesn't exist, and if it does exist, it'll load that into memory. So let's copy and paste that into our onCreate, import the class, and that's all we have to do. All right, well, we've set up our application, but we're not doing anything useful with it yet. What we want to do is be able to create a location model and a coordinate of that model and save that to the database. To do that, you would do that as you would do with any Java object by instantiating it, manipulating its data, And then finally with active Android, calling the .save method on it. So let me show you what that looks like. All right, so we have our code here. It's a little verbose, but I wanted to illustrate everything line by line so you got a clear picture of what we're doing. The first group of code is we're instantiating a location model that we created, setting its name and description, which are strings. And in the second group of code, we're creating a new coordinate object, which is another Java object, instantiating that, setting its latitude and longitude, which are doubles, and that'll set up our location model and link to a coordinate object. Now all we have to do for this database is then save it. To do that, we just call the save method on the new location model. Okay, we also have to save our coordinate object as well. And that's it. Active Android will compile this information into a SQL command and then insert this into the database. Okay, but we have a few problems here. One is we're doing this in the onCreate method of our activity, which means every time we create this activity, it'll insert a record with the same exact data every time. So if we launch the application 10 times, we'll have 10 exact copies of this data. But that can be kind of fun for an example, so let's try that out. Let's launch our application a couple times, and we'll come back to the video. Alright, I went ahead and launched the application a few times, which saved several records to the database. Now I want to retrieve those records, and then I'm going to loop through them and inspect them. I'm then going to change the latitude, longitude, and name of the record and then reinsert it into the database as an update. So first I'm going to comment out the code that creates these records, and I'm going to replace it with code that'll select all the records from the database. Okay, so once that code is commented out, what we're going to do is we're going to add a getAll method to our location model object. That's going to be a public static method called getAllItems that's going to return a list of location model objects. Okay, and the way that we construct this is we're going to return a new object using the select class and then using the builder pattern to call subsequent methods on that in order to construct our filters on the objects that come back. In this case, we want to get all the objects, so this will be very short. So we use the select method, so we need to tell it which database to select from. Well, we're in the location model object, so we're going to use that. So we pass this method a reference to our class, and once we constructed this call, we call .execute. Okay, let's test this out and see if our application actually saved all those records between launching the application, because each time that onCreate was called, a record was inserted into the database, so there should be a couple in there already. Now in our onCreate, instead of creating records, we're going to retrieve all of them that have been put in there from previous launches of our application. Using that static method that we created, we're going to call getAll on the location model object. Okay, and as you can see, we're not actually creating any objects in this particular launch of our application, but instead when the application launches, in our onCreate method, we're going to go to our database via the location model getAllLocations, and that's going to pass back a list that we're going to then inspect via the debugger. In order to inspect it in the debugger, we have to set a breakpoint on this line of code by clicking in the gutter here next to the line of code. Clicking that will add a red circle to denote that there's a breakpoint here. Now to launch in debug mode instead of running, we hit Control-D or click up here with the little bug icon. Once our application hits that breakpoint, code execution will stop. In the debugger, we can see our call stack, which shows that we're in the onCreate method that was called in the performCreate method in our Android app. Don't worry about any of the ones that are grayed out. Those are Android-specific methods that are calling your methods. Over in this window over here in the center, in the bottom, we have all of our variables that are in scope. We have this, which is the class that we're in currently, our saved instance state, which is passed in as a parameter to our onCreate method. As you can see, it's null, which means this is the first time that it's launching. The one that we're interested in is stored location models, but it doesn't exist yet because we haven't executed this particular line of code. If we hit this button here to step over our code or hit F8, the debugger will execute this line of code and assign our data to the stored location models variable. We can choose to step into this function, which means we can actually look at the code and execute all the different lines of code in getAllLocations and get a little bit more detail about how that works. Well, we know that that's only really one line of code, so we'll skip over that and just hit step over. And you can see that our store location models has 5 objects in it. We can inspect that by disclosing this arrow and inspecting each individual item. Now, of course, all these items are exactly the same. If we expand 0 and 1, you can see that their values are the same, except for one important field. This field called MID. In the first one, it has an ID of 1. In the second one, it has an ID of 2. This is very important because what SQLite does under the hood is assign a very unique identifier, or ID, to each one of these records. So even though these records are identical in name, description, and GPS location, they're unique records in the database. We can look at all the other ones, and their values are the same except for those IDs. So I launched the app 5 times and I have 5 records in the database. So this is really cool, but what happens if you want to manipulate that data? Well, using that ID, you can actually pull out individual records if you know the ID. If you don't know the ID, you can search on the other properties such as name or description, or of course the coordinate system. You can search the coordinate specifically based on the exact values of that coordinate, or you can pass in a range. You can query the database and give it a coordinate and say, I want all the coordinates within 5 miles of this coordinate. You'd have to do a little bit of math to figure out those GPS ranges, but this is certainly possible and very powerful. All right, so let's do a little bit more interesting things with this data. I'm going to pull out the first item in our database, change its value, and then resave that variable to the database. So let's do that now. To stop our debugger, we hit the stop button all the way on the left-hand side here. Now that I have a list of these location objects, I can loop through them and affect each one individually, or I can just get a particular one from this list that's in memory and manipulate it that way. So let's do it that way first. Okay, you can see here that I'm not actually creating a new object, but pulling one out of our array list that's stored in memory that we got from our database, changing the values, and then hitting save on it again. Don't forget to hit save. If you don't hit save, and you do another retrieval from the database, this record's values will be the same. So make sure you save it if you want to persist that to the database. Now I'm going to run our application just one time without using the debugger, and then the second time, after the data has changed, I'll use the debugger to stop on that first line of code. Okay, I'm just changing the location model's data. I'm not changing the coordinate system, so I just have to save the location model object. Okay, that should have changed our record. Now let's go back, put a breakpoint on that first line of code, and run it via debug mode. Okay, so our debugger stopped on this first line of code. Let's step over that code, and you can see that our stored location model still has 5 objects in it. Let's inspect that by disclosing this arrow, click on the first item, and seeing now our record has changed. Now let's stop our debugger so that we don't execute this code again. So far we created many models in our database by launching our application and executing the same code over and over and over again. Each time we launch our application, a new record gets saved to the database. Next, after we created those models, we queried the database to return all those models, changed the data in the first object, and then resave that to the database. Using the debugger, we were able to inspect those objects and make sure that they were persistent between application launches. Now we're going to show you how to delete one record based on a few parameters. If you want to return just one single object, you can refer to the documentation, which has a couple examples in how to do that. In this example, they have a where clause where they say category equals question mark and then the category ID. What this allows you to do is specifically for this, select an item where the category is specific to a particular value. This might have multiple items in it, and so they're using the order by, passing in the random function to pick out one random object from that list, and then calling execute single to retrieve one single object. Alternatively, you can say just execute, and that'll execute the query and return multiple items. So read through the documentation if you wish to do a little bit more complex queries of your database. To delete a record, we have 3 different options in Active Android. The first one is to load a specific object, namely one with ID equals 1, assigning that to a variable item in this example, and then calling delete on that item. You can do the same thing with one line of code by calling delete on your model, passing in a reference to that class, and then giving it the ID. If you don't know the ID of your class, you can use the third option. This allows you to delete from a particular class, in this example item, using the where method, ID equals, or you can pass it any column name. So in our example, we might say location name equals Boise, which will delete all the records in our database whose location name equals Boise. Let's go ahead and try the first one. Now, if you remember, we had 5 records in our database. What this will do is delete a location model with ID equals 1. That's the same object that we updated in our database. So after this object gets deleted, we should have 4 objects in our database, and all of those remaining 4 items will be the same. Okay, our application's run. Go back to our code, uncomment this line, comment this line out, rerun it in the debugger, step over the line of code, and now see that our stored location models list has only 4 items in it. Looking at the first one, we can see that it's the original values that we had put in, but the first item, even though it's at index 0, has ID number 2. Our ID number 1 was already deleted. Now let's try the second option to delete all items. Okay, I pasted in the code from the documentation, but instead of ID equals to 1 in our where clause, I want to delete a location with a specific name. We use the column name in our where clause in order to select those records to delete. So if we go to our location model, we can see that the location name column is equal to location underscore name. So replace ID with that name, replace the value with the value that you're looking to delete. Alright, we're going to execute this one line of code once, but you'll notice we'll have 4 records go to 0 after we run this line of code. To prove this, I'm going to refetch the data from our database. I'm going to run this in the debugger, and the first line of code should return 4 records. After delete, this line of code, which is identical, should only return 0 because we've deleted all the records with the name Boise, which happen to be all the records that we have in the database. Let's go ahead and run this and see what happens. Okay, our debugger has stopped on our first line of code, so let's step over that. Ensure that we still have 4 items in our store location models object. Step over the delete command. Now you notice that our store location model still has 4 in it because in memory, those records still exist. If we were to refetch it from the database by calling getAllLocations on our location model, you'll see that there are no records remaining because all of those records match location name equals Boise. So let's step over this line of code and see how many records we have left. Refetching from the database, you see that the size of the array that comes back is 0. And so that's how you retrieve, update, and delete data from an Android database using Active Android. I hope you found this tutorial useful. If you like it, click that like button. If you want to see more videos like this and more, click the subscribe button. If you have any questions or you found this video helpful, be sure to leave a comment below. Make sure you visit the website electronicarmory.com for more tutorials like this, and we'll see you next time.